When we talk about lighting, there are often misunderstandings and physical concepts that, in my opinion, are not very clear, and it's totally understandable because there is physics and mathematics behind these concepts. For this reason, today I want to explain you the most important concepts and physical measures behind lighting, in particular for sport lighting. Let's begin briefly understanding what is light. In physics, light can be seen in two different ways. It can be seen as a particle called photon or as a wave. Today we see the wave form. As all waves, light has some peaks. The distance between two peaks, one near the other, is called the wavelength. As all lengths can be measured in meters, but often is measured in nanometers, which is a very small unit of measure. A human hair has a diameter around 70,000 nanometers, so very small, and we have a range between 380 up to 780 nanometers, more or less, which is called visible light, and inside this range we see the light as light with our eyes. Outside this range there is also light, but we cannot see it with our eyes. For example, the microwaves used to eat the food, this is light, but we cannot see it. The first physical measure we see is the luminous power or luminous flux, and represents the amount of light our floodlight, for example, can emit. The formula is pretty complex, but it says that we need to keep all the wavelengths the floodlight emits and sum them, but waiting with the sensibility of our eyes. This because our eyes is sensible in different ways, even inside the visible light, to different wavelengths, and so we are more sensible to some wavelengths, so some colors of the light. The luminous flux is present in the floodlight or lamps datasheet, and it's very important to design the lighting system. If a floodlight doesn't have the datasheet, or the datasheet doesn't have the luminous flux, I will not use it. Let's move to Illuminance, which is measured in lux and is the ratio between the luminous flux, so lumen, divided by the surface of the object or surface to light, so square meters, and measures the quantity of light we seen from the surface, let's say. It's measured with a tool called Luxmeter, and is a final goal of our lighting system. Often regulations require a certain type of illuminance for the particular type of court or pitch. For example, the International Tennis Federation requires for a certain type of tennis court 300 lux, for example, as a mean value. Let's now see the electrical power, which is measured in watt. Is the amount of electrical power we supply the floodlights, for example, and so the floodlights give us light. A part of this power is transformed into light, and this is what we want, but another part of the power is converted into heat, and we don't want it. Electrical power determines also the amount of money we need to pay to light our court. The lighting efficiency is the ratio between the luminous flux, so lumen, divided by the electrical power, so watt, we supply to the floodlight or to the lamp. And this is a very important parameter to make a comparison between two different floodlights from different producers, or between two floodlights from the same producer but with different models. And in general, higher is this ratio and higher is the floodlight quality. Moving forward, we have the color rendering index, or CRI, which is identified with the symbol RA and is a value between 0 and 1, or 0% and 100%, and measures the color fidelity because light can distort how we see colors, and so we have this index. Sun daylight has a CRI equal to 1. In technical terms, the definition is a bit more complex, but for this video, let's make this assumption. Our floodlights can have a CRI spanning from 1 to lower values, so between 0 and 1. In general, for sport facilities, we have technical requirements which often says which is the lower acceptable value, so higher values are okay. And in my opinion, it's not very important as a parameter, so when we have an acceptable value, for me is okay. Then we have the IP protection grade. IP stands for International Protection, and is composed by two values, two numbers. And the first number represents the protection against solid objects, and also dust is considered a solid object. This value can span from 0 up to 6. Higher the value, higher the protection. While the second number is the protection against water. Again, higher the value, higher the protection. This parameter is very important to choose the right floodlights. Well, it can be seen as a very simple choose, but in our experience we saw many times customers who choose the wrong type of floodlights, not protected against water, then water made damages to their systems. In my opinion, for a sport facility, a good value can be from 56 to higher values, and if you choose outdoor floodlights, often you have at least this value or higher value, so no problem. As regarding color temperature, it's measured in Kelvin degrees and measures the color, the tonality of our light. Kelvin degrees are a measure of temperature, but also a measure of color. And this because every object emits light. Also me, I'm emitting light at the moment because I have a temperature higher than 0 Kelvin, but in my case this light is not in the visible light range. If we have hotter objects, then this light will be visible, and so we can measure the color with the temperature of an object that can emit light with this tonality. In our case, we can span from 3000 Kelvin, which is a hot color, let's say a bit yellow, and up to 6500 Kelvin, which is called a cold light, so a bit more shiny. We have also a natural light which is more or less around 5000 Kelvin. This because sun daylight can span from 4900 up to 5600 Kelvin, depending from season and latitude. As regarding sport facilities, some regulations requires a certain type of color temperature. In every case, I will recommend from 5000 up to 6500 Kelvin to have or a more natural light or a more shiny light, depending from the situation. The last important physics measure is the photometric curve, and is a graphic representation of how the floodlight emits light. This because a floodlight can emit directional light, so more focused, or can have a wider opening and so emit more light in the near, let's say. This value is, this graph is calculated putting onto the floodlight a plane perpendicular to the floodlight surface, as in this example, and on the plane we have a curve. The more common shapes are a very strict shape, which represents a focused light, or a more like a circle, more or less, which represents a wider opening of the floodlight. This graph is important to choose the right type of floodlight for the current situation. This because if we have small court, for example, for paddle or for tennis, with floodlights distant from the court, for example at 10 meters from the ground, we need focus the light. On the contrary, if we have a very big football pitch with floodlights less distant from the pitch, we will choose floodlights with a wider opening, so to distribute the light better. Our last concept, but not less important, is the lighting design project, which is the project of our lighting system, not from the electrical point of view, so the section of supplying cables, the type of circuit breakers and so on, but how many floodlights and what type of floodlights we need to buy and install to ensure our court has the necessary Illuminance. This is very important to ensure that technical rules are respected. And technical rules often does not only prescribe the value, but also how this value of luminosity must be measured. So, for example, in what points of the court must be measured. And so the project is very important to ensure the rules are respected. And so my advice is to require always, if you are making a new lighting system, to ask the lighting design to your floodlight supplier or to a third party, but always require it. Okay, this is all for today. Thanks for watching. If you have doubts or comments, in the comments or on our website, and see you in the next video.